Alrighty, we are going to start a review for our Unit 5 assessment. Let's look at this first question. Remember, this is going to be some questions from the past and then some questions from this unit. The first question says, the graphs of the function f of x equals the absolute value, blah, 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 and g of x equals this are drawn. Which one about the following statements of these functions are true? I'm just going to type both of these in. So let's type in the first one. Absolute value, math, absolute value, x minus 3, and then on the outside plus 1, and then my second one is 2x plus 1. Enter, and I'm going to look at a graph of them. Okay, the first one says the graphs intersect when x equals 3. Let me go to the table and see. X equals 3, are they the same number? No, so it can't be that one. Then it's saying the solution to f of x equals g of x is 1. So I need to find where is the point where they both are the same. Let's see. Where's the point where they're both the same? Are they ever the same? Oh, right here at 1, 3, 3. So the graphs intersect when y equals 1. No, it's when x equals 1, so not that. And now it's saying the solution to f of x equals g of x is 1. Or the solution to f of x equals g of x is 3. So we need to understand that f of x and g of x mean the same thing as y. So they're saying y equals y when y is 3. So answer choice D. Because this f of x means y, so y equals y when it is 3. Now let's look at this next one. This one says, first consider the systems of equations right here. Then consider this system of inequalities. When comparing the number of solutions in each of the systems, which one of the following statements is true? Well, equations could either have one solution, no solutions, or many solutions if they were the same line. These are clearly not the same line because we have different slopes, different y-intercepts, so it's definitely not that. So we either have one solution or no solutions. Let me type that in to see what it looks like. So we would have negative 1/2 x plus 1, and for the second one we would have x minus 5. And let's see a picture of what this looks like. Okay, so there's one solution. And now when we're talking about systems of inequalities, well, the first one looks something like this, and it's a greater than symbol, so we would shade above. And the second one looks something like this, and it's a less than symbol, so we would shade below. I should have made those dotted lines. Since they're not equal to, so it should actually look something like this. It should be a dotted line. Alright, so it would look something like that. So, both systems have an infinite number of solutions? No, that would only happen if the equations were the same line. The system of equations has more solutions? That's not true because the system of equation only has one solution. And the inequality doesn't have one solution. It has all those solutions inside the double shaded area, so that's not true. But it is true that the system of inequalities has more solutions. So answer, no, letter C. Let's look at number 3. To keep track of his profits, the owner of a carnival booth decided to model his ticket sales on a graph. He found that his profits only declined when he sold between 10 and 40. So between 10 and 40, I should see something going down. So let's see. 10 to 40, that's going up and down. 10 to 40, ooh, that's going down the whole way. 10 to 40, that's increasing. And 10 to 40, we're increasing and then we're staying the same. So B is the only one where from 10 to 40 we are declining, we're going down. Nice job. All right, let's look at number 4. The graph below represents a jogger's speed during her 20-minute jog around the neighborhood. Which statement best describes what the jogger was doing during the 9 to 12 minute interval of her jog? So from 9 to 12 minutes, what was going on? Well, it was staying the same, and that means the speed. Speed, same. She wasn't slow. She wasn't like not moving, because not moving would be her speed 0. And she wasn't standing still, because then she would have no speed. So she's definitely not standing still. Her speed isn't increasing, it's not going up. Her speed isn't decreasing, it's not going down. But she was jogging at a constant rate since her speed was staying the same. Nice. Let's look at the next one. The formula for surface area of a right rectangular prism is this, where L, W, and H represent the length, width, and height respectively. Which term of this formula is not dependent on the height? If I'm not dependent on the height, I don't want anything that has height in it. So I definitely don't want B, and I definitely don't want D. So now I'm between A or 2LW. Well, 2LW definitely doesn't have H in it, so that feels like an answer. A would not be my answer because in the formula of A, I have these two parts that I'm adding together that have H. So it wouldn't be that, it would be choice A. Let's look at this next one. Morgan can start wrestling at age 5 in the division. So at age 5, she can be a wrestler. So 5 can be included. So it wouldn't be C, it wouldn't be A, because 5 can be included since she can start at 5. He remains in that division until his next odd birthday, when he is required to move up to the next division. So at the next odd birthday, he's required to move up. So if I look at 7, these both have a closed-in circle. This one has an open and a closed-in circle. Well, let's think about it. A closed-in circle means that you're included. You can't be included in Division 1 at age 7 and Division 2 at age 7. You can only be part of one division, which means it would have to be letter D, which says that he is no longer included in Division 1 at age 7 because now he's included in Division 2 at age 7. All right, let's look at number 7. Number 7 is saying, solve the given systems of equations by inspection. We're just going to solve it by any method we see. All right, if I want to use the elimination method, 1 second here. The one thing I see wrong here is I need to rearrange these equations so they both say 5x plus y equals 7, and I need this one to say 5x plus y equals 9. I just needed to rearrange because I need the x's to be on top of each other. All right, these are already the same numbers. I just need to make one negative, so I'll make this bottom one negative. So I'll have 5x plus y equals 7, and then I'll have negative 5x minus y equals 9. 5x minus 5x is 0. Y minus y is 0. So 0 equals 7 plus 9 is 16. Is that true? No, which means there's no solutions. And let's see, if we were trying to get through the substitution method, we would have to make one of these equal to y or x. I'll just make this first one equal to y. So I'll end up with y is equal to negative 5x plus 7. And let me plug that into the second equation. I would have 5x. Instead of y, I'm going to put minus 5x plus 7 equals 9. Well, 5x minus 5x is 0, and 7 does not equal 9, which means no solution. So I can't supply a check or anything because there's no solution. All right, let's look at number 8. Which system of equation has the same solution as the system above? All right, if I look closely here, out of all the answer choices, the first one and these two are exactly the same. So let's look at the second one. Here, I see that they got 6x. They would get 6x by multiplying by 2. 2 by 3x is 6x. 2 by negative y is negative 2y. But 2 times 4 should be 8, and they didn't times that by 8. Let's look at the next one. 2 times 3x is 6x. 2 times negative y is negative 2y, and 2 times 4 is 8. I think this could be my answer. Let me just look at the other one to see. Well, I already know it shouldn't be plus 2y because 2 times negative y is negative 2y, so it's not going to be that. And now let's look at what they did here in D. In D, they went from 2x plus 2y to x plus y. In order to do that, they would have to divide each of these numbers by 2. 2x divided by 2 is x. 2y divided by 2 is y. But 16 divided by 2 should be 8, and they don't have that, so that's not our answer choice. Nice job. All right, let's look at number 9. Number 9 says, on the diagram below, it's a mapping diagram, and they want us to make something that is not a function. For something to not be a function, I'll say, this is not a function. I didn't even draw it yet, but I'm just already writing what I'm going to need to write. Because one input, which the inputs is set A, has more than one output, which will be set B. So an example of this would be having A go to B and having A go to A. Having one go to A and one go to B. That is not a function because, example, one goes to A and B. No good. I shouldn't type code number 1 in on a vending machine and have 2 things come out. That's not good. Alright. Now they want us to make one that is a function. So let's try this. This is a function because every input, which the input is set A, goes to one output, set B. So we just need to make every input, so we'll make 1 go to B, 2 go to A, and 3 go to C. That is a function because every input goes to one thing. 1 goes to B, 2 goes to A, and 3 goes to C. Each input is going to one output. Nice job. Alright, let's look at number 11. Which statement is equivalent to the inequality? Alright, I'm solving inequalities. So let me write this over here. I need to bring this 3x over, which means I'm going to subtract 3x, subtract 3x. I would get 9 minus 7x is less than or equal to negative 5. I need to get rid of that 9, so I'm going to subtract 9. I would get negative 7x is less than or equal to negative 14. And now to get rid of the negative 7, I need to divide. If I'm dividing by a negative number, I need to flip my inequality symbol, which negative 14 divided by negative 7 is positive 2. Right away, I could get rid of answer choice B, and I could get rid of answer choice D, because I should not have anything that doesn't have the equal to part. Because how'd I get rid of the equal to part? And then I just realized I forgot to flip it, so let me flip it. It would be answer choice A. Here you kind of got lucky because if you forgot to flip it, as long as you knew it was a positive 2, the only answer choice left was A. You can't start out with an equal to part and then get rid of the equal to part. That doesn't make sense. Alright, now let's look at number 12. Number 12 says, solve the given inequality and represent the solution set using set notation, interval notation, and graphically. Alright, let's solve this. To get rid of the 8, I'm going to subtract 8, subtract 8. I would have negative 12 is greater than or equal to 2x. To get rid of the 2, I'm going to divide by 2, and I will get negative 6 is greater than or equal to x. I always want my x, my variable, on the left side, so I'm going to flip this whole entire thing over, and it will look like this. So I'm going to put negative 6 somewhere on this graph. It's equal to, so I'm going to shade in the circle, and I'm going to go to the left. So this would be graphically. Now, set interval notation I already wrote, and now set notation means I need to realize that we're going towards negative infinity, and we're stopping at negative 6, which is included. Very nice. Alright, and now let's solve this equation. 2.5 times y is 2.5y. 2.5 times 2 is 5. Minus 1.5y equals 6. Add 1.5y to both sides. 2.5 plus 1 point. Ooh, I was about to make a mistake. These are on the same side. Whenever something is on the same side, you don't do opposite operations. You just combine the like terms like you would. 2.5 minus 1.5 is just 1.5y plus 5 equals 6. To get rid of the 5, I'm going to subtract 5. I'll have 1.5y divided by 1 equals 1 I meant, and now divide by 1.5, we get y is equal to 1 divided by 1.5 is 2/3. That in fraction form is 2/3. I made a mistake, so I want to make sure this is right. So I'm going to write 2.5 parentheses instead of y. I'm going to put 2 over 3, then plus 2 parentheses, negative 1.5, and times it by y, which is 2/3. And I need this to be equal to 6 if I did it correctly. It's not equal to 6. What happened here? Let me try typing it again. 2.5 parentheses, 2 over 3 plus 2 minus 1.5 times 2 over 3. I'm really close, but something went wrong. Let's see. 2.5 times y is 2.5y. 2.5 times 2 is 5 minus 1.5y. 2.5 minus 1.5 would be 1. Then we do 6 minus 5, which is 1. And 1 divided by 1.5 is that. What does that equal? 2 over 3. What is the matter here? Why is my check not working? 2.5 parentheses, 2 over 3 plus 2 minus 1.5. 1.5 times 2 over 3. Something is not working out. 2.5 times y is 2.5y. This is the mistake right here. 2.5 minus 1.5 is just 1. So this should have been 1, which means these should all be 1. See, this is why it's so important to check. And 1 divided by 1 is just 1. Now let's see if this is correct. 2.5 parentheses 1 plus 2 minus 1.5 times 1. That's correct. See? Very, very important to check. Alright, let's look at this next problem. Solve this. Hopefully I can solve this better. Bring the x over. So minus 0.01x minus 0.01x. 0.3 minus 0.01 equals 0.29x, which equals 2.9. And now to get rid of the 0.29, we're going to divide. And we get x is equal to 2.9 divided by 0.29 equals 10. And let's check 0.3. 0.3 times 10 equals that. And let's check the other side. 0.01 times 10 plus 2.9. Good. Both equal 3, so we're good. Alright, let's look at number 15. The Bundles and Boxes Shipping Company sells small boxes for 0.75. 0.75 for small boxes, plus 1.25 for large boxes. And then Carter bought a bundle of these boxes for $121. Alright, so I need this going on right now. Well, it's not going to be answer choice 4 because I see that they changed 1.25 to 1.24. So it's not going to be that. It's not going to be answer choice B or A because they're saying that the small boxes cost $1.25, which means that answer has to be D. The first equation is talking about how many boxes there are. The number of small boxes plus the number of large boxes equals 108. And then they're talking about the price of both ends up equaling the total price of 121. Let's look at 16. The Rodriguez family reunited reunion consists of 38 people who spent a total of that much money, and there was adults and children. So I need x plus y to equal 38. Which the only one I see there is A. Let's continue making sure that A makes sense. It's saying that adults and children equals 155. That sounds good to me. Alright, let's look at 11. What property of real numbers, 17 I meant. What property of real numbers is illustrated by this statement? Ooh, let's see what's happening here. Well, I see everything that's inside of the parentheses is the same. The only thing I see here is different is the order changed. Because I used to say A minus B, which A minus B is still the first thing. But then the A plus B went from being last to being second. So the order changed. So we would say commutative property because order changed. Alright, let's look at this next one. Hey, look, it's the same property. We have this, and then we have this. It's the same exact thing. Commutative property because order changed. Alright. Let's look at number 19. They want me to graph this inequality. Before I can do this, I need to make this y is less than or greater than. So I'm going to have y is greater than negative 2x plus 1. This means I need to start at positive 1 and put a point, and then I go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, then up 2 to the left 1, up 2 to the left 1. Let's see, dotted or solid. This means dotted, and then I also mean to shade above. So dotted line, arrows. I'm going to label it 2x plus y is greater than 1. I'm going to shade above the line. Nice job. And those are all our solutions. And number 20, they want us to do the same thing, graph this, but I don't even have to rearrange it. So negative 5, 1, 2, 3, 4, 5. And then 2x, so go up 2 over 1, up 2 over 1. Keep going, then down 2 to the left 1, down 2 to the left 1. This would be a dotted line since it's not equal to. Put some arrows, let's label it y is greater than 2x minus 5. If I'm greater than, I need to shade of above. And it's dotted because it's not equal to. Alright, number 20. Solve the given systems of linear inequalities graphically. Alright, first one, let's rearrange this. 6x minus y is greater than 5. Subtract 6x, subtract 6x. We get negative y is greater than or equal to negative 6x plus 5. And now to get rid of the negative 1, we're going to divide each number by negative 1. We get y is less than or equal to 6x minus 5. If you notice, I flipped the inequality symbol since I was dividing by a negative number. So I'm going to start at negative 5. Let me make this a grid mark first. I'm going to start at negative 5. 1, 2, 3, 4, 5. And now I go up 6 to the right 1. 1, 2, 3, 4, 5, 6 to the right 1. 1, 2, 3, 4, 5, 6 to the right 1. That is an equal to thing, so I can connect the points, put my arrows, let me label it. 6x minus y is greater than or equal to 5. And we're greater than, so shade above. And let's look at the next one. 4x plus 3y is less than negative 9. To get rid of the 4x, we are going to subtract 4x. Subtract 4x. We get 3y is greater than negative 4x minus 9. And now we need to get rid of the 3, so I'm going to divide each number by 3. It's positive, so I don't need to flip my sign. So I'll have negative 4 over 3x minus 3. So negative 3, we're going to go down 3. 1, 2, 3, put a point. Then negative 4, 3 says go down 4. 1, 2, 3, 4. Go to the right 3. Can't do that anymore, so now I'm going to go up 4. 1, 2, 3, 4 to the right 3. 1, 2, 3. Up 4. 1, 2, 3, 4 to the right 3. 1, 2, 3. And now that is not equal to, so it's going to be a dotted line. Put our arrows, label it. 4x plus 3y is less than negative 9. And we're shading below. Oh, it's actually a greater than symbol, my bad. So then we're shading above since it's a greater than symbol. And you're going to put a little s wherever the solution set is, which it's right there in the middle. And remember, solutions are only whatever's in that shaded area or whatever's on a solid line. Alright, let's look at this next one. Let's look at the first one. Negative x minus 4y is greater than or equal to 4. To get rid of the x, we're going to add x to both sides. We will get negative 4y is greater than or equal to x plus 4. Then divide by negative 4 to each side. And we will get y is greater than or equal... Ooh, I divided by negative 4, so I need to flip my sign. We'll have negative 1 over 4x minus 1. Alright, let's see this. Negative 1 means we go down 1 and put a point. And then negative 1, 4 means go down 1 to the right 4. 1, 2, 3, 4. Go down 1 to the right 4. Then up 1 to the right 4. 1, 2, 3, 4. Up 1. 1, 2, 3, 4. Put a point. Let's connect all of these. Put our arrows. And then shade below. Now let's look at the next one. 2x plus y is greater than 3. Subtract 2x, subtract 2x. We get y is greater than negative 2x plus 3. No multiplying or dividing here, so we don't have to flip the inequality symbol. Now we're going to go up 3. 1, 2, 3. And then negative 2 over 1 means go down 2. 1, 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. Now we're going to go up 2 to the left 1. Up 2 to the left 1. This is not equal to, so I'm just going to connect it with dotted lines. Label it. 2x plus y is greater than 3. And shade above. So our solution area is this little area right there. Nice job. And let's look at the last page. Deb and Luke go to this entertainment store and they purchase CDs C and DVDs D. Deb wants to buy 3 DVDs and 2 CDs for a price of $63. Then at the same price, Luke wants to pay $46 for 1 DVD, 4 CDs for $46. Alright, let's solve this. We could solve it either way we want. So I'm going to times this one by 1 and this one by negative 3. So I would get 3D plus 2C equals 63, since none of that changes. Negative 3 times 1D is negative 3D. Negative 3 times 4 is negative 12C. And negative 3 times 46 is negative 138. And let's solve. 3D minus 3D is 0. 2 minus 12 is negative 10C. And 63 minus 138 is negative 75. Now, divide by negative 10, divide by negative 10. We get C equals negative 75 divided by negative 10. We get 7.5. Alright, now let's go see how much DVDs are. We can use either equation. I'll just use the first one. So 3D plus 2, the CDs are 7.5 equals 63. So I'll have 3D plus 15 equals 63. Minus the 15, we get 63 minus 15. We get 48. Divide by 3, we get D equals 16. And using the second equation, I'm just going to make sure this is correct. If I purchase one DVD at $16 plus 4 CDs at 7.5, my overall price would be $46. Good job. Alright. Mrs. Wilson buys 5 hot dogs and 3 sodas for $7.75. Then the next person buys 2 hot dogs and 2 sodas. Oh, sodas is S, my bad. And 2 sodas for $3.50. Write and solve an equation to find this. Okay. Alright, I'm going to times the first one by 2. And since none of them are negative, the second one by -5. 2 times 5 is 10H. 2 times 3S is 6S. And 7.75 times 2 is 15.5. Then -5 times 10 is -10. -5 times 2 is -10S. And then -5 times 3.5 is -17.5. These cancel out. You'll be left with -4S equals 15.5 minus 17.5 equals -2. Divide by -4. We get S is equal to 1/2. So the sodas are basically 50 cents. Soda is 50 cents. I didn't mean to do that. Let me just save my calculator. Alright, the soda. I can never spell soda, so soda. Alright, let's go find the price of the hot dog. So 5H plus 3, we now know that sodas are a half, equals 7.75. So we'd have 5H plus 1.5 equals 7.75. Minus 1.5, we would get 5H is equal to 7.75 minus 1.5. We would get 6.25. Divide by 5. We get hot dogs are equal to 6.25 divided by 5 is 1.25. And hot dogs are 1.25. Let's just double check using the second equation. 2 hot dogs priced at $1.25 plus 2 sodas at 50 cents equals $3.50. Perfect. And that concludes our review on Unit 5 and some past things that we have learned.